Okay, so I am in test number 1, and I'm going to go over the problems that I want to review with you today. We're going over 1, 6, and hopefully 10 if 1 and 6 don't take too long. So let's start with number 1. The diagram shows the net of a triangular pyramid that has a total surface area of 106.5 square centimeters. The sides of the pyramid are dashed. So this is the sides. Which of the following is closest to the lateral surface area of the pyramid? Okay, we already know that total surface area is this. Total surface area meaning the area of all of these. The area of all of them added up, and that gives you this total surface area. They're asking for lateral surface area. Remember, lateral is faces, no bases. And on this pyramid, there's only one base, and the base is going to be this guy right here. So here's what we can do. These are all congruent, all these sides, all these faces and bases. So what we're going to do is we are going to find the area of this base, and we're going to subtract it from the total, and that will give us the lateral surface area. So these are our dimensions, and how do we find the area of a triangle? Well, if you have your formula chart, here we have the area section. Triangle is area is equal to 1/2 base times height. And I like to write that as area is equal to base times height divided by 2. So area is equal to 6.2 times 7.2 divided by 2. So 6.2 times 7.2 is equal to 44.64 divided by 2. 44.64 divided by 2 gives us 22.32 centimeters squared. So this is the area of this dude right here, this base that we don't want. So we're going to take 106.5, sounds like a radio station, and we're going to subtract that base, 22.32, put a 0 there, it makes you feel more comfortable. Then you're going to subtract 4 and 8, drop the decimal like it's hot, and it says closest to, so we have 84.18. So if we were to round this, we would get 84.2 centimeters squared. So that is going to be C. That is the closest to our correct answer. Okay, moving on to number 6. All right, number 6 says a large square pyramid made of glass stands at the entrance to the Louvre Museum in Paris. The diagram below shows the dimensions of the pyramid's base. It's 35 meters by 35 meters. It's a square. The volume of the prism is 8,412 cubic meters. What is the pyramid's height in meters? Round your answer to the nearest tenth. Okay, so they're talking about volume. So looking at volume of a pyramid, here it is. Volume of a pyramid is found by multiplying area of the base times the height and then by 1/3 or dividing by 3. And that gets you volume. But this problem is working backwards. So I'm going to write down the formula anyway because I'm going to need it. If we're talking about volume, it's a good idea to write the formula down. So they've already told us that this is the volume, and they want to know the height. So we've got some working backwards to do here. First thing we need is this big B, area of the base. So I'm going to find that by multiplying 35 times 35. And 35 times 35 is 1,225. Yeah, I'm using a calculator. I'm saving some time. So this is the area of the base. This is meters squared. So this is big B. Area of the base is this. So I'm going to take out the V, and I'm going to put in what they tell us the volume is, 8,412. And then big B is 1,000 225 times h, and all that has to be divided by 3. Now I've got to find out what this dude is. I've got to get h alone. So the first thing I'm going to do is multiply by 3 over 1 because I got to get rid of that 3. And this 3 up top and 3 on the bottom cancels out. So now I have 1,225 times h on this side, but what I do to one side I have to do to the other. So I have to multiply 8,412 times 3, which gets me 25,236. Now I'm going to divide by 1,225 because that's going to get h by itself, which is what we want. And divide by 1,225. And that's going to get us 25,236 divided by, it's going to get us this. And it says to the nearest tenth, so this is a 0, so if I rounded, I would just get 20.6 centimeters. And that needs to be bubbled into your answer document on number 6. Okay, you know what, I think we're going to stop there simply because of time. What I want you to do now is go to test number 3 and find a problem that looks like one of the two that we've solved today, or like anything that we've solved in the past. You need to be looking more for more of those problems that look familiar to you that you can solve yourself. And that's it, guys. I will see you on Thursday. Bye.